Hello, this is Benjamin Gordon, an MD PhD student at the University of Illinois at Chicago College of Medicine. This video is part of our Survivors Advising Scientists educational program, a bidirectional educational platform meant to connect our communities and increase scientific literacy and engagement. Our goal is to bring everyone to the table for scientific discussions related to cancer science and therapies. This is video number 2, components of a hypothesis. So before we dissect hypotheses into its components, let's review what a hypothesis is. Hypotheses make an educated guess. Hypotheses are testable and falsifiable. If you want to review more about hypotheses, please refer to our first module on hypotheses. So when a scientist or doctor sets up an experiment, he or she likes to account for multiple outcomes of the experimental results. So we have a starting point with an unsolved problem. Then we make a research hypothesis and set up experimental conditions to test your hypothesis. When you set up experimental conditions, there's two possible outcomes that could result of the experimental treatment. Outcome number 1, no effect, or the current explanation is what holds true because nothing changes. This is what we like to call the null hypothesis, or H subscore 0. Alternatively, we have outcome number 2, and this is the alternative explanation. You do see an effect, so the alternative explanation is true. Something changes. This is the alternative hypothesis, H subscore A. Now, this could get a little confusing because we have the research hypothesis, and then we have two outcomes with hypothesis in the name. So, to not confuse these, think of research hypotheses as the first prediction, and then null hypothesis and alternative hypothesis as the two possible outcomes. When researchers generally talk about their research hypothesis, they just mention their hypothesis without mentioning the null or alternative. When you specifically want to talk about the null hypothesis or alternative hypothesis, you bring up the name null hypothesis or alternative hypothesis. Let's go over an example used in a previous module. This example was about friends stealing your cookies. In this example, we had the following research hypothesis. If I put my next batch of cookies in a locked drawer, then my cookies will not disappear like they do in the open drawer. Now let's use our flow chart with this example and look at the possible outcomes. So we have a starting point in unsolved problems that friends are stealing your cookies from the drawer. In order to address this unsolved problem, we made this research hypothesis that locking up your cookies will help prevent them from being stolen. Now, the experiment is locking up your cookies. That's the experimental conditions. And we have two outcomes as a result of this experiment. One, we could have no effect. That is the null hypothesis. Nothing changes. You locked the drawer with the cookies in it, but your friends are still taking your cookies from the drawer. With this outcome, nothing advances your knowledge about cookie stealing because the current explanation holds true that friends are just stealing your cookies. And outcome number 2, locking the drawer prevents cookie loss. This is the alternative explanation that locking the drawer leads to a change. This is the alternative hypothesis, H subscore A. In a previous module, we also talked about the superscanner as a novel breast cancer detection instrument. We hypothesized together that if women undergo routine annual imaging starting at age 45 with the superscanner, then more cases of breast cancer will be detected earlier as compared to similar screening with traditional mammograms. Now again, let's use our flow chart. We have the starting point, the unsolved problem, that there are currently a lot of women who develop late-stage cancer because it's not detected early. Because of this unsolved problem, we created a research hypothesis that the super scanner will help detect breast cancer early. So that's our experiment. We're testing the super scanner against traditional detection methods. Outcome number one is the super scanner did not detect cancer any better than traditional mammograms. This is the null hypothesis. Possible outcome number two is that there's an effect. The super scanner does indeed detect cancer better than traditional mammograms. This is the alternative hypothesis. Now let's review. This is the null hypothesis, designated H subscore 0. And a good way to remember this is null starts with an N and no change starts with an N. The null hypothesis is what's already assumed to be true. It's the current status if there's no additional evidence to convince you otherwise. Now, there's specific language that doctors and scientists like to use when talking about the null hypothesis and experimental outcomes. Using this language and understanding this language can help you engage in scientific discussions. So, if experiments show a change, the null is not true, then you would say you reject the null hypothesis. If there's not enough data to show a change, then you say you fail to reject the null hypothesis. So here is our flow chart. And let's say you have the starting point, you set an hypothesis, and outcome number one, the null hypothesis turns out to be true. You say, I fail to reject the null. Let's say you perform an experiment, but instead of outcome number one being true, outcome number two, the alternative hypothesis is supported by the data of the experiment. You say, I reject the null. Let's move on to the alternative hypothesis. This is the hypothesis that challenges the null, and typically it's consistent with the research hypothesis. The research hypothesis is a prediction. And typically, when you make a prediction, you predict a change based on your experimental conditions. So that's why very often the alternative is very consistent with the research hypothesis, because the research hypothesis makes a prediction of change, and the alternative hypothesis is that change. Now, the language you use around an alternative hypothesis. If experiments show a change, the null is not true, then you can accept the alternative hypothesis. If there's not enough data to show a change, then you do not accept the alternative hypothesis. So again, just to visualize this, we could use the example of the cookie locking to prevent it stealing. So let's say you lock up your cookies, but your friends still take it, and the null hypothesis is true. Nothing changes after you lock up the cookies. You say, I do not accept the alternative. Let's say instead you lock up the cookies and your friends no longer take it. The alternative hypothesis is that locking the cookies prevents cookie stealing. You say, I accept the alternative. I think locking up the cookies prevents them from being stolen. Here's a review, a recap. So we have the null hypothesis, H subscore 0. You reject the null if evidence goes against the null hypothesis. You fail to reject the null if not able to produce evidence that goes against the null hypothesis. For the alternative hypothesis, H subscore A, you accept the alternative if evidence supports the alternative hypothesis, H subscore A. You do not accept the alternative if evidence does not support the alternative hypothesis, H subscore A. Let's use one more example here to make it an everyday example. So you have the waiter serving pepperoni pizza to a customer here. And since they served the pizza with pepperoni on it because the customer asked for pepperoni pizza, that is our null hypothesis. The null hypothesis is pepperoni pizza. The waiter then goes up to the customer and says, do you want me to add pineapple on your pizza? And the customer does not like pineapple on their pizza. Since this is the change, The alternative hypothesis is pineapple being added to the pepperoni pizza. Now let's see what the customer says. The customer says, I failed to reject the null. Therefore, the customer is clinging on to the null, which is pepperoni pizza. They do not want pineapple on their pizza. Here are some questions to think about when approaching a scientific experiment that could help you organize the hypotheses and the expected outcomes. So when you read the results, you can organize the results based on what you may predict or the different possible outcomes. So, what is the null hypothesis? What is the alternative hypothesis? What would it take to reject the null hypothesis? What would it take to accept the alternative hypothesis? This is the end of this module. I'd like to take this time to thank Dr. Kidieski and the administrative staff of the University of Illinois Cancer Center for their support in this endeavor. Additionally, we'd like to give a special thank you to all the cancer patient advocates who provided feedback in the development of these modules. We'd also like to thank you for reviewing this module, and we invite you to send any feedback on this module or suggestions for future content. Please feel free to move on to the next module, number 3 on experimental variables. Thanks again.